Okay, let's dive into this. Look, we all know modern businesses absolutely run on data, right? But what actually happens when the systems trying to process all that data just constantly trip over each other? Well, welcome to today's explainer. We're going to unpack the architecture behind Snowflake. It's this platform that literally re-engineered how organizations store, access, and process data to solve what is arguably the industry's biggest bottleneck.
To really grasp the problem Snowflake solves, I want you to just imagine Netflix for a second. Think about it. They're tracking every single thing you watch. They know exactly when you pause, what you search for, what you skip. They have millions of users, and this data is growing every single second. But here's the really tricky part. The recommendation team, they need that data right now to figure out what you're going to watch next. And at the exact same time, the marketing team is analyzing it to see which shows are trending globally. Oh, and the finance team is digging into the numbers to track premium user growth. So how on earth does a system handle all of these different teams demanding answers from the exact same data at the exact same moment without making your Friday night movie buffer? It's a massive challenge.
And Netflix definitely isn't alone here. Think about apps like Swiggy, handling live orders and delivery times, while their data scientists simultaneously try to predict demand. Or banks, right, like HDFC, where every swipe, every UPI payment, every loan needs to be secure, available, and instantly analyzed for fraud. Across all these modern businesses, we see this exact same pattern of shared data challenges. You've got this huge volume of data, multiple different teams needing access to it, this uncompromising need for speed, and data that just continuously grows. There's no pausing it.
Now, for decades, businesses relied on traditional databases to handle all this. But they all share this massive, glaring flaw: storage and compute are tightly coupled, meaning they live inside the exact same system on the exact same servers. It's kind of like a restaurant with just one kitchen, where all the chefs are forced to cook together at the exact same prep station. What happens? Absolute chaos. If one chef is making a massive, complicated feast, which is like a heavy data query, everyone else's orders slow down to a crawl. And if you want more space, well, you have to buy a completely new, bigger kitchen for everyone, which is incredibly expensive and, frankly, super slow.
So the crucial point is that Snowflake stepped in and introduced a massive game changer. They completely decoupled storage and compute. They looked at the old way, realized it was totally broken, and built a system from the ground up that separates where your data permanently lives from the engines that actually do the thinking. I know it sounds simple, but it's a monumental shift. It literally eliminates the chaos of that crowded kitchen entirely.
So how do they do it? Snowflake achieves this decoupling by splitting its architecture into 3 completely independent layers. Going back to our restaurant, it's like taking that chaotic setup and giving it a separate walk-in freezer just for ingredients, a separate kitchen just for cooking, and a separate dining room. Storage, cooking, and serving are all entirely separate operations now, so they never get in each other's way. Let's actually break these 3 layers down so you can see exactly how this magic works.
All right, the first layer is cloud services. You can think of this as the intelligent brain running everything behind the scenes. It handles proving who you are, your authentication. It keeps track of where your data lives with metadata management, and it figures out the absolute smartest way to answer your questions, which we call query optimization. Honestly, think of this layer like a high-end hotel concierge. You walk up, right, and say, hey, I need a table for 4 and a cab to the airport. That concierge doesn't physically carry your bags or drive the cab. They coordinate everything flawlessly in the background so your whole experience functions perfectly.
Now, right beneath that brain is the storage layer. This is where all your data actually lives, permanently, and more importantly, securely. Snowflake stores this data in a highly compressed, optimized, columnar format on major cloud providers. We're talking AWS, Azure, Google Cloud. But to make it really clear, the best analogy here is a self-storage unit. Your data just sits there safely and organized, and you're only paying for the actual space it takes up. You're not paying for expensive computing engines to babysit your data 24 hours a day, 7 days a week. It's incredibly cheap, and remember, it's completely separate from the processing.
Now, what's really interesting about this next part is the third layer, virtual warehouses. These are the only components in the entire system that actually compute. These are the engines crunching the numbers and answering your queries. A virtual warehouse is essentially this independent cluster of computing power that spins up the exact second you need it, does the heavy lifting, and then, this is key, shuts completely off when it's idle. And because they're completely separate from the storage layer we just talked about, you can run multiple compute clusters simultaneously. Your data science team and your finance team, they each get their own dedicated workers. That means they literally never step on each other's toes. And this completely eliminates what we call resource contention. In traditional systems, you're waiting in line. But Snowflake's separated architecture gives you zero contention. It is exactly like a Netflix streaming library. The movies, which represent the data here, they sit centrally in one place in storage. But a million different people can hit play and watch a million different films at the exact same time without anyone seeing a buffering screen. Multiple teams, totally different workloads, accessing the exact same data simultaneously with absolutely zero conflict. It's brilliant.
Let's actually apply this to a real-world scenario so we can see the superpower in action. Picture an e-commerce company on Black Friday. The stakes literally couldn't be higher. Your analytics team urgently needs to run these massive, heavy sales reports to see what's trending right now. And at that exact same moment, your data engineering team is trying to load massive amounts of fresh, incoming clickstream data. In a traditional data warehouse, these workloads would fight over the exact same resources, basically killing each other's performance right when you need it the most.
But here, we see how brilliantly Snowflake solves this. You just simply spin up separate virtual warehouses for the different teams. You can give the analytics team an X-large compute cluster for their heavy reporting, and simultaneously, at the exact same time, create a medium cluster for the engineering team to just load the data. They both hit the exact same centralized storage simultaneously. There's no copying data, there's no waiting in line, and most importantly, there are zero slowdowns for anybody. Let's move to another scenario and see how this builds into some incredible cost savings through a feature called auto-suspension. Imagine a fintech company that runs heavy month-end reconciliation reports. With old-school on-premises hardware, or even an always-on traditional cloud cluster, you are paying for that server around the clock, even when absolutely no one is using it at all. You are literally paying for idle time. But with Snowflake, your storage persists super cheaply, and your compute engines automatically suspend at the second they aren't working. I really want you to think about what that means. That's over 700 hours of idle time every single month. Let's say that fintech company's month-end report takes, 2 hours to complete. That means for the remaining 700 plus hours in that month, that compute cluster is sitting completely idle doing nothing. Snowflake automatically suspends the compute warehouse after just a few minutes of inactivity. So for those 700 hours, your compute bill is literally zero. Zero. And the moment a new query hits next month, it auto-resumes instantly. You're only billed per second, strictly for the compute you actually use. And you know this architecture also totally revolutionizes data sharing. Imagine a massive healthcare network. You've got 3 distinct groups: the clinical analytics team, the billing department, and an external insurance partner. And they all need access to the exact same patient encounter data set. Historically, you'd have to make secure copies of the data for each team just to prevent system crashes. But with Snowflake's multi-cluster architecture, they all simply tap into the single central storage layer, each using their own separate compute clusters. Zero data copies required, which obviously means much better security, and a single unified source of truth for everybody. All of this brings us to the ultimate payoff of Snowflake's design. It's perfectly captured in their core philosophy: store data once, compute anywhere independently. And really, this is the brilliant secret of decoupling. Because storage, compute, and cloud services are all independent, companies gain 3 massive superpowers. They can scale compute power up or down instantly without moving a single inch of data. They can share data seamlessly across endless teams without any resource contention. And, as we saw, they save enormous amounts of money by never paying for idle engines. Which leaves us with this final, somewhat provocative thought. For decades, data systems forced organizations to compromise. It was always a trade-off. You could be fast, or you could be cheap, or you could be flexible, but you could almost never be all 3 at once. Snowflake completely changed the rules of the game here. So I want you to take a hard look at your own systems. If your data platform still forces you to make those painful trade-offs, are you truly ready for the cloud era? Well, thank you so much for joining me to decode this incredible architecture in today's Explainer. Stay curious and keep exploring.